Now, finally, we're over here now. And if we know ahead of time that, where is it? Here it is. If we know ahead of time that our function that we're working with is continuous and non-negative in a closed interval, then to compute something like this really means we're computing area, because we already know that this can be interpreted as a Riemann sum. And Riemann sums, when we've seen working with positive functions, are actually an example of computation of area, finding area. So we can interpret this as area as long as f of x is a positive function. And therefore, if we can find that area, we can find this integral. So that means that, as I did before, I kind of overshot it. Really, we're just finding the area under this rectangle. It would be the equivalent of calculating the Riemann sum, which is the equivalent of calculating this so-called definite integral. So we can see that our definite integral would be 1/2 base height, which is 1/2 2 times 6, which is a 6. So we see that is a 6. Okay, now the problem is you can't always assume that you're working with a nice geometric formula to compute that area under the 3x. I keep drawing this in here. This is y equals 3x. That's the line. Okay, so now that was such a short one. Maybe we can grab another one here. Well, maybe not. Okay, on the next try.